Hello. We're going to go over session 3 real quick. So, first question, we are looking at some tiles that they use to decorate on buildings and walkways in Mexico. So they show us the first 3 stages of the pattern that they use. We want to know how many tiles are needed to make stage 40. So we're only at stage 1, stage 2, stage 3. We need to go all the way to stage 40. So if you look down here, one thing that stays the same in every stage, the first and last row have a total of 4 tiles. So if you look, these outside tiles stay the same in every single stage. That's why if you look down at their expressions down here, they keep 4 constant. And that's why we call it a constant term, because it's not going to change. The 4 is going to stay the same no matter what stage we're on. There's always 4 tiles on the outside. So what is changing is our exponent, our base and our exponent here, depending on which stage we're in. So for stage 1, they have 1 to the power of 2. For stage 2, they have 2 to the power of 2. Stage 3, they have 3 squared. Stage 4, they have 4 squared. So stage 5, we could guess would be 5 squared. And don't forget, we would leave our 4 plus. So if we go all the way down and we skip to stage 40, we're going to have 40 squared and then plus the constant 4. So we're looking for how many tiles would this be if we had to solve it. Down here they go and they show that you could write the expression 4 plus n squared, where we're talking about n is whatever stage number we're on. So again, we're just plugging in or substituting a number for n depending on what stage. So for stage 5, we put 4 plus 5 squared. For stage 40, we put 4 plus 40 squared. For stage 8, we would put 4 plus 8 squared. So that n is where we're substituting our number of the stage. So if we go down here, I'm assuming they want us to actually solve it. Let's go ahead and just do that. So order of operations is kind of what we're getting into. You can say PEMDAS, some people say GEMDAS, kind of just depends on how you want to say it, but quick review. So G stands for grouping, and you may want to write this in your textbook somewhere. So grouping could be parentheses, it could be brackets, it could be those weird squiggly braces. So grouping always comes first. In this case, 4 plus 40 squared, I don't see any grouping symbols, so we can be done with that step. The next one is exponents. So if we look at our expression, do I have any exponents? Yes, I do. I have this 40 squared. So I have to solve that part first before I do any addition that's in my expression. So 40 squared, we talked about yesterday, does not mean 40 times 2. It means 40 times itself 2 times. 40 times 40. Remember the quick trick, 4 times 4 would be 16, and then add those 2 zeros back on. So we have 1600. And then we bring the rest of our problem down, so we've got the 4 plus. So all we did first is we did our exponent. So we're done with step number 2. Now we can move on to any multiplication or division. And we solve from left to right. So you don't always do multiplication first. It's multiplication and division on the same step, whichever one you get to first from left to right. Well, in this case, look at our expression up here, 4 plus 1600. I don't have any multiplication or division, so I can move on to my last step, which is addition and subtraction from left to right, whichever I get to first. In this case, there's literally only one thing, so it's 4 plus 1600. And hopefully we are able to add that together without writing anything down. So it'd be 1604 or 1,1604 tiles at stage 40. Let's look down here. First they did 4 plus 3 squared, so they're kind of going through how they ended up getting all of these other examples up here. Place parentheses so that we get 7 squared, blah, blah, blah. How many tiles are in stage 40? We just figured out it was 1604. With or without exponents. How do exponents fit into the order of operations? Remember, these go together from left to right. So you could say it's the second step. Let's go down and look at another problem. So Tamara is using rice paper to make Japanese lanterns. The expression 2s squared, I will go ahead and write this down because we know we'll need it, plus 40s represents the surface area of a lantern where the base edges are s inches long. So we're not sure how long they are, but it says s inches long. What's the surface area of a lantern where S is 9 inches? So here we've got another situation where we have to substitute a number in for S. So we're going to go and we're going to put in 9 anywhere we see an S. Now here, notice I'm not just going to put 29 squared. That is not what this says. Remember, if a coefficient is right next to a variable, that means to multiply. So it's 2 times 9 squared. If you want to do the multiplication dot, you can. If you want to do the parentheses, you can. You can use an X, but remember, sometimes once we have letters in our algebraic expressions, it looks like multiply. So I'm going to put 2 times 9 squared plus 40 times 9. It's not 409, 40 times 9. So I'm going to solve, let's see, do we have grouping? Technically, no. Sometimes people get confused by parentheses and say, that's grouping. Nothing's grouped inside there, though. So that's not really grouping. I'm just using that as a multiplication symbol. So we don't have any grouping. Let's move on. Do we have exponents? Yes, we do. 9 squared. So I need to do that part first before I do any multiplication. It comes before multiplication. So 9 times 9, 9 times itself. Remember, it's not 9 times 2. 9 times 9 is 81. Then I'm going to bring everything else down exactly like we see it. I'm not trying to solve multiple things all at the same time. So now in this step, do I have any exponents left? Nope, I'm good to move on. So now let's look multiplication and division from left to right. So I'm going to start here on the left and start looking. I'm going to solve multiplication or division, whichever I come to next, which this is the first one. So 2 times 81. Again, if you need to write it down, you can. But I know that 2 times 1 is going to be 2. I know that 2 times 8 is 16. So I really don't even need to write that down. I'm going to bring everything else down exactly like I see it. You could solve 40 times 9 at the same time, but I would just, to be safe, do one thing at a time. So now I see that I've still got multiplication and division, so I'm going to do 40 times 9 next. I'm just going to keep this number the same. 4 times 9 is 36. Add that 0 back on. Now I have no multiplication or division left, so I'm moving on to addition, subtraction. So it is my very last thing to do. I do go left to right, but there's only one thing to do. So I'm going to add 360 plus 162. 2 times 6 is 12. 3, 4, 5. 522. And notice, because I'm bringing down everything one step at a time, you should slowly start to see it kind of makes a V. Lots of people call it like a little pizza slice with your little, pepperonis and toppings. This is your crust up here. Some people like to call it an ice cream cone with a little gumball at the bottom. However you want to think about it, make sure that it kind of makes a triangle shape, and that means that you did it correctly. Let's look at the next one. What is the value of the expression 5 parentheses 3 cubed minus 4? So I'm going to leave my GEMDOS reminder over here. Let's get rid of my check marks. So, do I have any grouping? Yes, I do. I see these parentheses here, so I've got to do this grouping first. Well, notice inside my grouping, I also have exponents. I've got subtraction. So within my grouping, I'm going to kind of restart the step. So within my grouping, do I have another set of grouping? No, not really. I don't have any more parentheses inside the parentheses. So do I have exponents though? Yes, I do. I have 3 cubed, which remember means 3 times itself 3 times. 3 times 3 is 9. 9 times 3 is 27. So if I just solve this part right here, I get 27. Now, have I finished everything inside my grouping? No, I haven't, because I haven't done anything with this. So I have to bring that down and bring my grouping symbols down because I'm not done with everything inside the groups. So now I'm going to go over here and restart. Do I have any grouping? Yes, I do. I've got parentheses around 27 minus 4, so I have to do that next. It's going to give me 23. Now, if you want to drop your parentheses, you can, because everything in the grouping is done. However, make sure when you bring down this 5, it doesn't look like 523. You need to put a multiplication symbol, or again, you could put parentheses around the 23, and it's not really grouping anymore. It's just signifying multiplication. Do I have any exponents? No. Moving on. Do I have multiplication division? Yes, I do. That's all that's left. So I've got to do 23 times 5, and that is 115. Notice I've got my little pizza slice here. Yay! So 115. Last but not least, on this one, we have our variables, and then they tell us what each number is equal to, or each variable is equal to. So I have to substitute in first, and then I'm going to go solve. So the value of m, well, it says m is 5 plus 4n squared. Well, I know that n is 2. So I'm not going to write 42 squared. I'm going to write 4 times 2 squared. Or you could do parentheses if you want, but you have to make sure that you're multiplying 4 times n squared. Then I'm subtracting 5q, and I know q is equal to 3. Again, it's not 53, it's 5 times 3. And then there's a plus 4 at the end. So we've got a pretty long expression here. Let's start with our GEMDAS. So do I have any grouping? No, because I didn't use any parentheses this time. Let's move on. Do I have any exponents? Yes, I do. So I have to do this part first. 2 squared is going to be 4. And this is where you're going to hate us, but you have to write everything down. Do not go and try to solve a bunch of stuff at the same time. Everything else stays the same. You're going to underline to show us that you only did this part. Everything else stays the same. Bring it down exactly like you see it. So now, on this step, do I have any exponents left? Nope. I'm going to move on to multiplication and division from left to right. So I'm going to start on the left. I'm not going to solve addition yet. I'm not there. I am going to do this first multiplication, which is 16. I'm going to bring everything else exactly like I see it down. And here's where if you underline, it will help you because you won't lose any of these symbols. You'll know, okay, I haven't used the plus sign yet. I haven't used the subtraction yet. I haven't used any of this yet. So we would underline as we go. So let's see if I got rid of all the multiplication and division from left to right. Let's move along. Addition, subtraction. Here's another multiplication. I have to do this next. 5 times 3 is 15. Everything else comes down exactly like we see it. Okay, now do I have any more multiplication or division here? I don't. So I can move on to addition, subtraction from left to right. So the first thing I come to is 5 plus 16, sorry. So I'm going to have 21. Everything else is going to come down exactly like I see it. Sorry, I'm kind of running out of room here. So I did that part first. Everything else came down. Still going left to right. So now I'm going to do 21 minus 15. Keep in mind, I keep seeing my kids not subtracting correctly. They'll say 1 minus 5 is 4. We cannot do that. I can't take 5 away from 1. So don't forget your first grade little borrowing here. 11 minus 5. Bring everything else down. Now we're at our very last thing, 6 plus 4. So this should be our answer. Notice this is a big old piece of slice here. Whee! This is the Big Mac Daddy Supreme. Okay, so I substituted my numbers in and then I solved. You have to go in order. grouping first, then exponents, then multiplication, division, then addition, subtraction. Make sure if you need to write that on your paper over and over and over and over and over again that you do, okay? We want you to go ahead and do the practice pages, and we will post a video so you can check that later. Good luck.